Hello everyone, I'm Tim and I will introduce my idea about the mahjong board. And I'll start with the simplest model. After drawing one tile, my 14 tiles and all the tiles shown on the table are used as information to calculate the best way to discard tiles. This calculation method is also used for whether certain tile acts true upon or count. First add x to my tiles to form 14 tiles and then calculate the best tile to discard. If the tile discarded is not x, choose true upon or count. I'll always declare mahjong to win if I can. Notice that the calculation method did not consider the three opponents' unidentified tiles, but only considered my own 14 tiles and all tiles on table as information. This is obviously lazy, but I did not think of any good way to guess the other three opponents' unidentified tiles. My evaluation of the way that the tiles and discarded could be represented by a graph. In the figure, the circle shows the state of 13 tiles, the square shows the state of 14 tiles, and the triangle shows the state of 14 tiles that can be declared mahjong. Here, I have not considered the parts that cannot be changed after draw upon a count. Of course, these can be added as part of the status. Information will not change the main transfer method. The state of each 14 tiles is connected to no more than 14 circles. There may be duplicated tiles in the 14 tiles, which are the states of the remaining 13 tiles after enumerating the tile discarded. In this way, the square state is easier to calculate. Use f of x to represent the estimated value of the state where 14 tiles are recorded as x, g of y to represent the estimated value of the state where 13 tiles are recorded as y. Then f of x equals to max g of y1, g of y2, etc. g of y14, where max means choosing the best state and discarding the corresponding tile for transfer. And for the triangle state x0, f of x0 equals to the final score, considering the difference between the scores of self-drawing and make more mahjong from opponents. I simply use 1/4 and 3/4 to sum them up. As for the calculation of g of y, it will be very complicated. Each round will consider all the remaining tiles, that is, all tiles excluding my own 14 tiles and all shown tiles on table. Enumerate the tiles that are still remained and calculate the probability of this tile until upon count on mahjong or self-draw. This transition probability can be recorded as P of y and x, which means the transition probability of y to x. This is also part of probability that is not transferred. That is the situation where tiles cause the game to end is recorded as Py. In this case, a penalty value needs to be set, because I don't know if it's caused by which it's not easy to predict the probability, so it's temporarily set as an unknown constant phi. The formula looks like this. Since there are only 34 different tiles in total, n will not exceed 34. For P of y and x, the probability of draw is the number of needed tiles divided by the total remaining number. As for draw upon count and make mahjong, First, judge whether the Y state meets the condition, and if it meets, there will be some extra additions. P of Y is also difficult to calculate. I simply treat it as a function that monotonically increases with the current round number. In this way, if you can calculate this f of x, g of y, you can get a very rough figure of which type to be discarded, but the number of states is too large to calculate all of them. Fortunately for f of x, there is a good optimization space for max, and p of y and x is usually less than 1 in 10, resulting in a significant difference as the transfer between f of x and g of y. The estimated value of the triangle state is very large, and the estimated value of the transition from one level to g of y will decrease by one level. Suppose the distance between g of y and the nearest triangle state is d, because the transition between f of x and g of y always alternates. The transition distance from f of x to g of y is not considered here. It can be understood that the state of y needs d tiles to make mahjong, so the state of distance over d plus 1 can be directly ignored. As shown in the figure, the calculation of circle 1 does not need to calculate circle 3 if the level of the triangle state is recorded as 1. When circle 3 contributes to circle 2, the contribution level at this time is already 0. It decreases by one level. For the top square in the comparison between circles 1 and 2, the contribution of circle 3 doesn't make much difference. Of course, if the difference of 1 in 10 is not too large, one more layer can be considered. In the implementation, I try to calculate one more layer within the time allowed, and I will stop the calculation if the time is up. Final implementation. In this way, if we can enumerate some triangle states that are close to the current 14 tiles, and then find the intermediate state of the transfer path and the states of the surrounding layer, we can roughly get the calculation with these fewer states, while enumerating the tile types of mahjong tiles. Except for the special tile types such as 7 pairs, 13 units, leather honors, and knitted tiles, knitted straight, etc. They can be enumerated separately. The enumeration of these special tile types spends little time. Combined with my 14 tiles, the search process can be optimized with the level of probability. How the normal tile types can be enumerated together. It can also be optimized. However, at the beginning of the game, due to the fact that there are too many possible tile types, it is impossible to enumerate them completely. Fortunately, some simple enumeration and artificial common strategies can give some simple directions at this time, such as the most isolated tiles are usually discarded. As the number of rounds increases, the 14 tiles gradually approach the margin tiles, and the calculated results will become more and more instructive. Regarding some of the coefficients mentioned earlier, I set them to relatively ordinary values and did not conduct a lot of testing and modification. About strategy, For the 13th tire state y, P of y is obviously very complicated. It does not simply change with the number of runs. A natural idea is that the probability of making an opponent win is related to the tires discarded. Therefore, I have tried to avoid discarding dangerous tires when there are many runs, and specifically calculate the probability of making an opponent margin based on the characteristics of some tires and the status of the remaining tires. That is to change the method of calculating f of x like this. F p x minus y represents the probability that the tire is discarded safely, but I did not use this more complicated model to calculate, only considered all the current 14 tires and make a comparison with p x minus y to decide which tire to discard. As for the later situation, using current information to estimate is not accurate. This part is very subjective, and the effect is not good. Although the probability of making an opponent win has been reduced, it also caused to sacrifice a better way of discarding tires to make mahjong. In the end, I gave up this strategy. In addition, if the opponent knows this defensive strategy, it is easy to find countermeasures and make my strategy useless. This means that if the strategy is used in one game, it should not be designed to be constant, and at the same time, it needs to have the ability to recognize other opponents' strategies. Rely only on tires that are discarded by them, and between runs, the program is not allowed to learn through human's memory. I don't have good way to do this. In summary, my boat still has a lot of things to be finished and improved. Since I am doing this alone and the results of other tasks are not obvious, I make a stop here. As for some other ideas, such as using a large number of games to train the fitting value between tiles, using accumulated experience like this may have a better effect than a zero-start search. That's all. Thank you.